All right, so 1.22 is the first one?
Something like that, yeah.
All right, so this is a 2-star one called Filter. Shut up! FilterIn that takes a predicate. Remind me, what's a predicate?
I think with question mark.
Yeah, well, that's typically the naming convention for predicates is things with question marks. But what is a predicate? I think we have it in the slides, don't we?
Tests the variable type. Checks against the variable type.
Well, those are examples of predicates. I don't think they all have to be that.
Say a function that takes in one parameter and returns a Boolean value.
Yeah, single parameter function that returns a Boolean. Because like we could take in a number and say, is this guy even, for example, or is it a power of 7? Is it a list of values that sums up? Well, actually, that would take 2 parameters, so that won't work. Okay, so we're going to filter in a predicate onto a list, and this returns the list of those elements in list that satisfy the predicate. Okay. All right, so what is it called? FilterIn. Define FilterIn like that to be a lambda that takes a predicate and a list, and we're going to go through every element of this list, and what are we resulting in? A new list with only the elements that predicate return true for? Filter in. So number across this. So A is not a number. We kept a 2. This guy's not a number. This guy's not a number. We kept a 7. So only the elements that the predicate returns true for. Right?
Yep.
All right. So we are going through every single element of the list. We have that pattern, right? So if null LST, and we also know we're building a new list. So typically when we're building a new list, our endpoint is empty list, right? Because we're going to be consing stuff on. All right. Now we want to ask the question, if we have something, if we have a car of the list, we want to know if the car of that list, so if pred car of list, if that's true, then we will cons car of list onto filter in pred coder of list. That's what we do if when the predicate applied to the first element of the list boils down to true. When that guy is true, we cons that element, because the predicate was true on it, onto whatever filter in returns for the rest of my list. Make sense? Otherwise, we'll just call filter in on the predicate of coder of LST. So I don't want to keep the guy I just looked at, so don't keep him, and just call predicate again. All right, so the reason your answer was it allows you to test for a data type is all the examples they gave you were these. So like number, question mark, symbol, question mark, these are predicates that happen to be built into the language, but we'll use an example here in a second. Let's just test against this real quick, or I'll write my own predicate. What happened? Did I screw up?
No,
I don't think that's that one.
That's for the next.
Oh, this is in that question.
That,
So I did screw up. All right. So there's that guy.
yeah.
All right, and we've obviously tested it on all possible inputs. Now, if I wanted to find my own predicate, I'll call this guy my pred. This is going to be a lambda that takes in a single parameter, as Jack pointed out. All right, so it takes in a single parameter and must boil down to a Boolean. That's the definition of a predicate. We got a bunch of them built into the language. Is something a list? Is something a symbol? Is something a number? Okay, is something null? And naming convention says that predicates tend to have a question mark at the end of the name of it. But look at this. I have gone against the grain here. No question mark in my pred. Okay, because we're rebels. Alright. You guys are becoming ultimate nerds if you're getting my code jokes. Yeah, I know, this is getting pathetic at this point. Because I think I heard everybody laugh. Alright, good. Alright, so my predger. Oh, yeah. Alright, so this guy, I don't know what he's even going to test. Let's just say, let's see if he tests for even numbers. So if... Actually, we can just boil down to this. We can boil down to, what was it, modulo? So EQ, actually we'll just do this. Equal modulo, that is the modulus function for this, right? X2, 0.
Gives an O on the end.
Yeah.
Oh, well, I said it right. I spelled it wrong. I said modulo.
Finish that.
Okay. No, I don't think so. I just can't spell. All right. So this guy really tests for evenness, right? We pass x in. It says if x mod 2 is equal to 0, this will boil down to true, right? That's a Boolean expression. Equal sign. This will boil down to a value of 0 or 1. If it's equal to a 0, this will boil down to true. If it's equal to a 1, this will boil down to false. So this is a predicate, this is a function that takes one parameter and boils down to a true or false. So now what I can do here is I can pass in my predger like this, and it should boil down to, I wonder what's going to happen when I try to apply modulo to a list. Let's just find out. I might not be happy. But in any case, this should just give us a 2. Yeah, expects an integer as the first parameter. So we'll just doctor it. Yeah, whatever. So it'll work on that. Just going to give us the even numbers for that, so just the 2. Because that's what this predicate does. This predicate expects a single input. It happens to require that input to be a number because of the math function I'm using here. Modulo says I can only give you answers if you give me numbers to work with. That make sense? So this is my own function I wrote here, my pred, and I'm calling that, I'm filtering that guy into this list here. That makes sense? So we get what predicates are now? Any function that takes a single parameter and returns true or false. That's what a predicate is. What? Did you say like a Boolean? Yeah, true or false. It returns a Boolean. Any function that takes a single parameter and returns a Boolean. All right. Questions on FilterIn? And that was a 2-star? Man, this is a joke. I'll give you a lot more next time. And then next one is 1, 2, 3. This one?
Yep, 1, 2, 3.
All right, ListIndex, pred, list returns the 0-based position of the first element of list that satisfies the predicate. If no element of the list satisfies the predicate, then ListIndex returns a false. What function does this sound like that you've used in Java a bunch of times?
Index of.
Index of. So index of says, return for me the position of the first occurrence of some value. or -1 if it's not found. This guy returns false if it's not found. All right. So list index. How many of you thought about that when you were writing this one? That list index sounds a lot like, it seems a lot like index of.
I mean, it sounded familiar, but I didn't actually think too hard about it.
So define list index, and this guy is a lambda that takes in a predicate and a list. Right. Yeah, predicate and a list. Yep. And he's supposed to return the first position in there where it finds where predicate is true for that guy. Okay, so let's go ahead and write this with a helper. Most of you probably used a helper. I think there's a way you could accomplish it without a helper.
I was thinking about that, and I couldn't come up with a solution.
Well, you'd have to, the real problem is the starting point, the 0, because you can just keep adding one until you finally get to your place, and then it's just a sum, and you boil down to a 0. But how do you
start with that 0?
Yeah, you would need the helper. Yeah, doesn't matter. If you're going to need a helper anyways, you might as well throw the count in. Define list index helper. This guy's going to take be a lambda, a pred, a list, and call the current pos. And then what this guy will do is he'll call list index helper, and he'll pass it pred, list, and 0. That's the first bucket you're checking, is bucket 0. All right, so we're going through every single element in our list. That's a pattern. If null list, then if no list, instead, we're not building a list here, right? What's the pattern we're doing? We are trying to tell you the position of something. So this is our end case. This says, hey, I have run out of things to check, and the assignment says return a false. That's the value, right? There's a capital F.
It's lowercase.
Lowercase f. Nailed it. All right. So if I'm out of stuff to check, boil down to false. This is the proverbial -1 from index of in Java. They just, I mean, if you wanted to change this to a -1, you can. Just the actual assignment said boil down to false if you don't find it.
So the hashtag, what is that?
It's just the how they represent trues and falses in this language. Yeah.
Like, I was trying to specific to that.
No, it's not a syntax thing. That's the Boolean false literal. I think there's actually a couple other ones that might work. I think that is actually equivalent.
Capital also works.
Yeah, but and I mean, actually, it's a good question you asked, because these would be like the examples of little nuances between languages, right? So we learned scheme in like 20 minutes, right? We just kind of said, this is how you define things, this is how you ask questions, this is how you accomplish repetition and write functions, right? Then as you get into the minutia of it, you start running into the little nuances, like, oh, well, this is how I say false or say true in this particular language, right? In Objective-C, you know what, how many of you have ever used Objective-C before? Okay, trues and falses. Do you know how you say trues and falses in Objective-C? Yes and no.
Yikes.
Yeah, it's interesting. It's actually, Objective-C is, to this day, maybe one of my favorite languages. Just, it's a, I don't know, a fun language. I like all the square bracket syntaxes, and yeah, it's just I don't know, just interesting. You know, it feels, I don't know, like kind of you're writing in Latin or something.
Jeez.
Because it's dead.
Huh?
Is that because it's dead?
Actually, Objective-C,
Does it use more than Swift for iOS programming?
probably not anymore unless you're using an older code base. But I guarantee the Apple iPhone developers were not complaining about Objective-C. Swift is there to lure Android people over because when you first look at Objective-C, it's intimidating. It's once you get past that original thing, if we sat down and say, how do you define variables? The same way you do in Java. How do you ask questions? The same way you do in Java. How do you write functions? Almost the same way you do in Java. The way they represent static versus non-static is actually, like in Java, static, you put static there, non-static, you just omit it, right? In Objective-C, a static function has a plus sign before it. An instance function, a non-static function, has a minus sign before it.
Okay.
So it has syntaxes for both. Yeah, I mean, it's not dead, and it's just as good as any other language, and I don't know.
I wasn't sure you said that, so I was like, is that
Yeah,
language? So-
maybe at some point I'll probably do that in some class that you'll have with me at some point. We'll just use Objective-C in that class.
Can we also get a class where you use Turbo Pascal?
We need it. Well, you probably could find an online interpreter. Turbo Pascal was just the name. It's not a language. That's just the
Right.
name of the Borland compiler for Pascal was called Turbo
Borland is
Pascal.
awesome.
Who?
Hackathon.
Yeah, Hackathon must write code in Pascal. Pascal's fine. You could account. Pascal's effectively teaching C.
Okay.
It was a language developed for teaching to make things a little bit more, at the time, let's call it palatable than like the C programming language. But C is fine. There's nothing wrong with C. People are just afraid of pointers and stuff. But pointers exist in Pascal. So it's anyway, just stupid.
We should do some hackathon in R.
Well, R is Java syntax.
Yeah.
Yeah, so
Okay.
we would just be applying it to data science.
Yeah.
All right. What was I talking about? Oh, we're in the middle of a function. Okay, got it. So we're doing our normal pattern here where we are checking each element of a list, and forget about what even we're checking it for. We're checking each element of a list, and when we run out of things to check, what is my final result? In this case, my final result is, hey, I survived to here, and I got nothing for you. Here's your false. Otherwise, I must have something for you. So we're going to ask the question, if pred, when applied to the car of list, if that guy is true, then what are we going to do? We are going to boil down to pos. That's where I found that value. No more recursive calls or anything like that. Just boom, found it. Make sense? Else, if I didn't find it yet, I'm going to go ahead and I'm going to call ListIndex helper, passing it the same predicate, passing it the cooter of my list, and passing it one more than pos.
Oh,
That was simple.
I like that.
Well, do we even know if it works yet?
Oh, no idea. It's probably gonna break.
It's working. It's because it's been-
Well, it either works because I'm still waiting for my first bug, or I purposely introduced an error as a teaching moment. No, that would be intentionally. I said purposely.
Oh,
Unintentionally would mean it's my first bug. So, yeah, so the first guy in here was well, actually, that's not, oh yeah, bucket 1. 0, 1. That should return a 1. That's the first time I ran into a number.
make sure it returns false.
Yeah, I'll test all of them. Because that's what the cool kids do. There's our 0, and this one should be a false. My right eye stopped working there for a second. There we go. It's actually funny. We return an F, but it actually displays it as the, so that must actually be the the actual literal for Boolean false.
Yeah, I didn't use the pound F. I just typed in false and that works. Exact same.
Oh, really? Just false?
Yeah. They'll do the exact same thing.
I bet you it doesn't do the same thing. I bet you get. Yeah, let's test it real quick. It'll give us the false. Oh, it does. It does. So it does. It maps it to it. I was thinking it was going to give me a false without the thing here, which would have been a string literal. And then if we tried to like test it against a Boolean, it would have failed. But no, it.
I'm willing to bet that's an implementation level detail.
Oh, yeah, I'm sure.
Yeah.
I'm sure it just treats this guy as a synonym for false.
So
Okay.
the hashtag, is there a requirement in Boolean false, or is that just?
I don't know. There's probably a official structure of the language, like how you call trues and falses. Let's just say it's the hashtag T, hashtag F, but it looks like there's 500 or 600 synonyms for it.
Like equals, okay.
So,
Oh, those aren't synonyms.
Well,
I know,
they're all
but they're all
different.
like synonyms.
They're all different.
all right. So questions on this?
I have a question.
No. What's your question?
So, okay, for example, like the third one, when I say simple, so you go through 1, 2, and then A, B, and then B. So then I feel like it's keep tracking the post, but then how is it return false?
This is not a symbol.
No, like,
Yeah. So
yeah, because you have.
we checked 0, not a symbol.
Okay,
We checked 1, not a symbol.
okay.
We checked 2, not a symbol. We checked 3, not a symbol. We are now out of places to check. What did we return? False. I didn't use pause. I have pause here. I could return pause here if I really wanted to. And there's my 4. That shows me I walked off the end of my list. 0, 1, 2, 3. So I'm sitting out here at bucket 4 and saying, look, I didn't find it. I'm off the end of the list. But I didn't use pause for that last thing. When I ran out of stuff, I returned false.
So then, since you cannot find it, does that mean is take off the loop?
No, okay, so I see where you're getting confused. This is the wrong. Oh, no,
Very
this
hard
is-
to say.
That is false.
Like, so you cannot find it, does that mean the false statement already done? Would that mean you take off the loop and go back to the true statement?
No. So notice here that if we find it here, we just boil down to pause. We are not calling the function again.
Yeah.
So we're done.
Mm-hmm.
There's no breaking out of the loop. There's no anything. It's over
Okay.
with pause there. If I didn't find it yet, this is what I am calling it recursively, passing it a new version of pause and a cut down version of my list. When I finally run out of things to do, I'm just boiling down to false. Notice for all these, I'm not building stuff like I used to. Like our normal pattern is like we're consing something onto whatever is returned by something else. In this case, I'm not doing that. This guy doesn't make any recursive call, and our one recursive call here isn't waiting for any other response. It's just saying, look, I've done what I can do. Next guy's chance. Next guy's turn.
Okay.
All right, that makes sense? All right, so let
But then
me...
you're still keeping track with the pulse, right?
Well, I'm still keeping track of pause. I just don't use it. When I run out of stuff to check, doesn't matter what the value of pause is. I was only keeping track of it to, remember where I was in there to give some sort of result. Okay, so let me... Where is 470s? All right, so this was 2223. Okay. Let's get to some difficult ones now. All right, so 26.
There's merge sort.
What's up?
No,
Yeah, there is merge sort. And that is definitely going to be one of your homework assignments.
Oh, no.
All right, so it's actually not merge sort. It's the merge step of thing. This is the one I just did, right? So I need 1.24. All right, 1.24 says called every. This returns false if any element of the list fails to satisfy the predicate and returns true otherwise. So this is actually pretty similar to what we kind of just did. We're going to go through every single element of a list. We're going to ask the question, does this guy fulfill our thing? If I run into anybody there who doesn't fulfill it, I'm boiling it down to false. Otherwise, keep checking. Okay, so that's define every to take in was just a predicate in a list. Predicate in a list. We'll ask the question if null list, if I'm out of stuff to check, everything must have been good. I didn't hit anything in there that broke. Otherwise, if not pred car list. So if this guy is not equal to true, which means it's false, then boil down to false, else called every on pred coder of list. So let's test that. So all of these guys are not numbers, right? So this should be false. There's our false. And all of these guys are numbers. So that should be true. And there's our true. All right, questions on that one? We're going to chug past these next couple easy ones so I can give you hard ones. You did that in 30 seconds. It's my way of just breaking your spirit.
I was like, how do you think that so fast?
Well, remember, he's been writing the same programs year in and year
I know.
out.
No,
for the past 20
I only
years.
teach this class every 2 years.
Okay, every other year. for the
You
past-
don't remember what you had for lunch last week. I do. Some of them I recall, like, oh, I've done this one before, but yeah, I have to solve them in real time. I'm on this one exists. Returns true if any element in the list satisfies the predicate, false otherwise. Okay. Define exists.
Shall not write that.
Replacing.
Lambda and predicate. All right. So we want to return true if any element satisfies the predicate, false otherwise. So same pattern. If null list, if I'm out of stuff to check, that must mean I did not run into any of them. That satisfied it. So I'll boil down to false. Otherwise, if pred applied to car of the list, if that's true, go ahead and boil down to true. Otherwise, call exists on the same pred and the footer of the list. So if I'm out of places to check, return false. Otherwise, they ask the question, does the car of the list return true for the predicate? If it does, I found at least one where it's true, boil down to true. No more recursive calls. Else, go ahead and call exists with the same predicate on the rest of the list. If I run out of things to check, I'll ultimately return false because I never actually ended by returning true. Well, I guess I can't copy and paste this one. It's like a ninja one. Can I do this one? All right, we'll just assume this works. All right, so 1.26 up list removes a pair of parentheses from each top level element. All right, so we have a list like 1, 2, 3, 4, and we're creating a new list with these parentheses removed from it. Okay, so from each top level element. So in this case, the second one up, this is a list whose first element is this guy, and whose second element is just a Z. So it's not a list, so we have nothing to do. So we avoid doing anything to it if it's a list. You know what? I might want to give this one to you as an assignment. This is kind of a good one. Up and flatten are both pretty good.
Flatten is the whole thing. Ooh, with S.
But if I do another one of these, I can give you merge. Yeah. All right. So let's do up. So we'll define up to be a lambda that takes a list as a parameter. And this guy is going to go through every element of the list. So our normal pattern, right? So if null list, and we are building a list. So we'll boil down to the empty list. Otherwise, I must have a car to the list. So I have the car to the list, and the car will be a list. So what I want to do is I want to remove the parentheses from that list. Does that make sense? So the car of my list might look like this right here. So now let's just solve the subproblem. If I have a list that looks like that, how do I turn it into just 1 and 2?
Could you append it to the empty list?
Can I append it to the empty list? So if I have the list 1, 2, and I append it to the empty list, I'll be stuck with the list 1, 2.
Append, not copy.
Yeah. The list 1, 2 is a list. The empty list is a list. You append two lists together, you're left with one list with the contents of all of them. So it'll be the list 1, 2.
Yeah. So so going back from 1, 2, so you're going to do 3, 4 first for the cursive call, and you have list 3, 4 and list 1, 2 appended together. So it's one list of 1, 2, 3, 4.
Yeah. So you're right on the append. Okay, you're right on the append. So
Doesn't append put it at the beginning though, so you'd end up with 3, 4, and 2?
no.
We asked if the
What's
person
it
was
at the
a
beginning?
list.
Is that cons?
If yes,
They
then
both
that
put it
to
as
the
forward.
answer. Maybe. No,
But if
that's
you're
that.
passing in, 1, 2, if you're only passing in one at a time.
Oh,
Unless you
yeah.
wanted to not have a list possibly at the very end.
It's done.
Yeah.
I think that's it.
That's it.
So there's our 1, 2, 3, 4. So that's the magic of append, right? So we know the difference between append and cons. Cons takes an element and puts it onto the front of a list, where append glues two lists together. So I took the list 1, 2, and I appended it to whatever up returned on the footer of the list, which was the list containing the list 3, 4. And what did I do for the list 3, 4? I appended the 3, 4, the list 3, 4, onto whatever up returned on the footer of the list, which was the empty list, which is effectively the question you asked. So what happens if I append the list 3, 4 onto the empty list? I'm stuck with the list 3, 4. What happens if I append the list 1, 2 onto the list 3, 4? I get the list 1, 2, 3, 4. That make sense?
I have a question.
Sure.
The other one, there's a second one. There's like a second thin one. There's a list within a list. I want to see how that works.
Well, it'll work the same way, because this list within a list, this is the element. It's a list containing two things, where the first element is X and the second element is a list. It doesn't recursively go into it.
Oh, duh.
Yeah, I mean,
That's just one half of the next
you
one.
could write it differently.
No, because I was thinking this. Oh, so that's pretty simple. I thought let's go inside and do something. Oh my gosh.
Did I write this funky?
Because you use an element, but it's expecting a list.
Oh, I never actually test for a symbol. Yeah. So I actually need to ask another. So I'm not actually done. I need to ask that question. If symbol car list then we will cons car list onto up footer list. Otherwise, I do my append thing. So if we look at this example here, I might have an element of my list that isn't actually a list. It's a symbol.
So,
Okay. And actually, do they give examples? I don't know. Do they say that it can be a symbol, or do they say it can be almost anything? Well, here
We can check for.
we'll just say not list.
Yeah.
So if not list that guy, if the car of the list is not a list, just cons it onto whatever up returns. Otherwise, do my append thing. Got parentheses issues. If not that, do this, else do this. Don't have enough parentheses. There we go. Blaine, this is your job to make sure I don't misspell list.
Oh, sorry, I wasn't watching.
Didn't we assign that to you last time?
oh, hang
I
on,
know
you
I'm
missed
still doing
another
it.
one. Car.
Blaine.
I can't use expletives in this
That's
class.
pretty cool.
All right, so there we go. Syntax is fine, I just can't spell. All right, that make more sense? So let me give this to you as like some samples. So that's up, that's every, and list index was part of the homework, right? So for your homework, we're going to do flatten, so 27. We're going to do merge, 28.
Oh, good lord.
And sort, 29.
No?
Oh yeah, that's a good one.
Goodness.
And you cannot use the built-in sort function.
There's a built-in sort function.
I think so. There's at least a pretty decent chance there is, so don't use it. All right, so 27, 28, 29 for homework?
Oh.
Man, it's like the death. Look at this. Merge, sort. Merge, sort. It's the thing of nightmares.
Do you have a guess what the weekend homework will be like?
Way worse than that. Let's see.
And I have to get all of these done today.
Yeah, here's a sort on the predicate.
Good luck with that.
There's a chance I might do this in class next time. Oh man, the 1 stars, maybe one.
Is that a word problem?
Yeah.
These are,
That's descriptions. Is that-
no, these are binary tree functions. Super easy.
Oh my god.
That's why it's a 1 star. It's super easy. Probably 130 through 133.
Gosh.
Oh man, maybe 134. Worst case through 134. 'Cause I'll probably do some of the ones for your next semester or next class. But I really want you to have a 3-star over the weekend. Oh man, this one is crazy too. Man, people don't recover from that one.
It's a
Have I asked for
17.
mercy?
I've seen students like go into infinite loops on this one. We got to go pull them out of bed. All right, so 127, 128, 129 for next class.
7, 8,
That's correct. All right, and then some number of questions between the next 3 and the next 7 after that one. Probably with the final one being that 3-star. So basically, Godspeed. Is what we're saying.
So basically,